n factorial over n minus k factorial times x to the n minus k. Okay, so back to the factorial shit. Give a good hard think of what you think d to the 1/2 of x to the n would look like. Since I don't want the entire class to sit in silence again, I'll just give you the answer. It's n factorial over x minus 1/2 factorial times x to the n minus 1/2. Okay, so you're probably asking yourself, what the fuck does x minus 1/2 factorial even mean?
I know, I was thinking that very same thing, Trevor.
I'm sure you were. Well, it's obvious, and it follows from what we've learned in other classes, and thus left to the reader to try to figure out. Please note that you should have a great deal of frustration if you don't know what you're looking for. This is intended by the author. Just kidding, I'm not every other fucking math textbook author. I'll tell you, but we gotta do some remembering. Do you remember the gamma function from Math 365, probability?
You know I don't.
Me neither. But I looked it up, right? You're welcome. It's on page 99 of the textbook, by the way. Right, so the gamma function is gamma of n equals n minus 1 factorial. But this only really works for positive integers.
Fuck.
So, okay, so if you read a little bit more in the textbook, or you just Google it, you'll see that you can generalize this for all positive real numbers. Here's the function. You're welcome. The gamma function implies that n factorial equals gamma of n plus 1. The left-hand side is only defined for positive integers, but the right-hand side, you see, is defined for all of fucking r, the positive part.
Ye fucking hot!
And that, my friends, is what we gotta use for the x minus 1/2 factorial. So, using these super sexy substitutions, I can try this again.
Oh, I'm keeping that in there. You don't have to redo that. That was perfect.
I'm doing it.
Okay.
So, using some super sexy substitution and manipulation, we get this. I'm not saying that out loud because it's just too much. But who cares? If we're dealing with the natural numbers, let's get real. We'll replace n with alpha, like this.
Nice one, Trevor.
Okay, but let's show that d to the 1/2 of d to the 1/2 of x to the alpha equals x to the alpha prime, or just that first derivative, which is equal to alpha x to the alpha minus 1. Buckle up, fuckfaces, and watch this.
That's funny. I'm not reading that.
Yeah, me neither, but it's okay. We'll give them like 5 seconds to screenshot this and come back to it. Just kidding, I'm moving on right now. So with these sorts of definitions and such, we can confidently, don't you dare ask questions, just trust me and say fair enough.
Fair enough.
Good. Say that this. So, if we want to find out what d to the 1/2 of, say, x is,
And we do.
we use the function to see that it's equal to this. Bada bing, bada boom, bitch.
By the way, if you really want to know how to do this, I'll send you a link to the YouTube video where we learned where all this came from.
I won't do that, don't email me.
And if you thought that was cool, check this out. Recall the Fourier transform.
Hey, I know those words. That kind of seems like how the ideas slash results slash concepts are connected to what we've learned in class.
You got it. From here, we see when we integrate by parts, we get, because negative 2i lambda doesn't have anything to do with x, we can pull it out front and get it.
Just yeet it out.
But this is just, why does this even matter? Well, the second derivative, do you see what's happening?
Hell yeah, I do.
Now we have the motivation for fractional derivatives. If you take the Fourier transform of the fractional derivative, in application, we want the half derivative of the half derivative to equal the first derivative. So what is? Start by taking the big hat. Fourier transforms are one-to-one, so we can remove the hat Indeed, the half derivative of the half derivative is equal to the first derivative.
So there you have it, folks.
Fractional derivatives and Fourier transforms.
Let's hope that you didn't end up with 0 points in the end.
See you next time, Math 420.